Suppose we have a piece of paper on the ground, and that piece of paper experiences two forces that act on it simultaneously. One force is a 4-mile-an-hour wind blowing from the west, and the other force is a 3-mile-an-hour wind blowing from the northerly direction, as you can see right there. Where is this piece of paper going to go, and how fast will it go? Such a problem is said to be solvable by using vectors. Check this out right here. We can actually take these vectors and add them. Now, a vector is a mathematical quantity with both magnitude and direction. And as you can see right here, direction is just as important as magnitude, or how strong the force is. So if we can actually take these vectors, take this force, and we can decompose it here as follows. We can actually have this wind vector blow first on this piece of trash. So the trash is here. This arrow is going to bring it right over here, right? And then let's suppose the northerly wind comes after the fact. And now it's going to drag it right down here. Well, using that logic, we might as well say that that piece of paper then went from here all the way to like over here, right? Now the question is, how fast of a vector, how fast of a wind is that going to be? Well, if you look at this, you'll see, gosh, we have a right triangle here. And we could solve it by just simply doing this, right? The length of that vector plus the squared plus the length of that vector squared, or the magnitude of that vector squared, is equal to the magnitude of the resultant squared right there. Do the Pythagorean theorem on that, and you'll get that piece of paper is going to be blowing now at 5 miles per hour, right? And we could actually go ahead and look at this even deeper and say, what direction is that going to blow in, right? I mean, it's blowing southeast, right? So if we consider that direction to be pure south right there, then this angle right here, using right triangle trig, is going to be 53.1 degrees approximately, right? And so the bearing will therefore be, the bearing there is going to be south 53.1 degrees east. And here's a problem that illustrates the addition of two vectors.